The overall goal of this procedure is to demonstrate a lensless on-chip fluorescent microscopy platform for imaging fluorescent objects over an ultra-wide field of view. To accomplish this, a thin absorption filter and a fibre optic faceplate are gently placed on top of an optoelectric sensor array, or CCD-CMOS, and then a microfluidic chip is positioned on top of the faceplate. Next, a prism is assembled with the microchip through the use of index matching oil. Fluorescent excitation is achieved through the side facet of a rhomboid prism, and the holographic illumination is done through the top facet of the same prism. Ultimately, high-resolution microscopic images can be obtained from the acquired fluorescent images by decoding the raw images through digital algorithms. If needed, the decoded fluorescent objects can be automatically counted using a custom-developed interface.
On-chip lensless imaging in general aims to replace bulky lens-based optical microscopes with simpler and more compact designs.
This emerging technology platform has the potential to eliminate the need for bulky and costly optical components through the help of novel theories and digital reconstruction algorithms.
The lensless on-chip imaging platform comprises several optical components, including a digital sensor array, an incoherent illumination source, a prism, an absorption filter, and a fibre optic faceplate or a fibre optic taper. In this platform, different types of sensor arrays can be used for detection of the fluorescence signal from target micro-objects. For the purposes of this